All right, so this section is 8.4, systems of nonlinear equations in two variables. All right, so it's just like solving systems of equations or system of linear equations. Talked about that in the previous section, but this time we have nonlinear equations. So you're talking about quadratic or maybe circles. So remember, we can use either one of our methods to solve, and you choose which one would be best depending on what you were given. A lot of times what you're given will dictate whether you use the substitution method or the addition method or the graphing method. But of course, we're not focusing on the graphing method, but I will show you a rough sketch of what these will look like and how they will intersect. All right, so let's look at the first one. Want to solve x squared equal to 2x plus 10. I said x squared equal to 2x. X squared equal to 2y plus 10. And then 3x minus y equal to 9. So notice the first equation is quadratic. The second one is linear. You know, quadratic is made that because of that square. All right, x squared. So I chose the substitution method. So if I'm going to use the substitution method, that means I need to take one of my equations and solve it for one of my variables. Easiest one is to take this one right here and solve it for y. So that's what I did here. I added y to both sides and subtracted 9 from both sides. So y is equal to 3x minus 9. So I solved that second equation for y. Once you found that, you go ahead and substitute into the other equation what y was equal to. So the other equation, equation 1 was x squared plus, equal to 2y plus 10. Go ahead and plug in 3x minus 9 for y. And then we have this result, x squared equal to 2 times 3x minus 9 plus 10. All right. Now we can go ahead and solve that. Distribute 2. So that'll be 6x minus 18 plus 10. Combine your like terms, negative 18 plus 10. So we have x squared equal to 6x minus 8. Now, if you want to solve your quadratic equation, you want to set one side equal to 0. So I subtracted 6x and added 8. And that gave me x squared minus 6x plus 8 equal to 0. From here, you want to solve it quadratically. You can either use your factoring skills, quadratic formula, completing the square, whichever way you want to do it. Just know that either way will still give you the same answer. So I went ahead and factored, got x minus 2 and x minus 4. Set both of those pieces equal to 0 and solve. So I will have x equal to 2 and x equal to 4 for my x values. Once you do that, once we do that, you go ahead and plug those values back into either one of those equations to get the corresponding y value. So you need, remember, these are ordered pairs. Remember, we didn't have x or y. We found our x's. Now we need the corresponding y values that match with those x's. Doesn't matter, and you go back here. Here are our original equations. It doesn't matter which one of those that you use, as long as you do everything correctly. That second equation, remember I solved it for y, so I'm going to use that form of it. So that's what I wrote right here in purple. I'm using y equal to 3x minus 9 because I've already solved that equation for y. And I plugged in 2. 3 times 2 is 6. 6 minus 9 is negative 3. Plug in 4. 3 times 4 is 12. 12 minus 9 is positive 3. All right. So when x is 2, y is negative 3. When x is 4, y is positive 3. So those are our ordered pairs. And here you see I have a rough sketch of how that would look. Remember, we had a parabola and a line. And so the line goes through the parabola at those 2 points. So if you had to solve by graphing, that's how you would have done it. You would have grabbed both points. I'm going to graph both lines. Where they intersect would be your answers. All right. Let's look at the next one. Here we have x minus y equal to 3. X minus 2 squared plus y plus 3 squared equal to 4. So over here in the purple, you see I pointed out the first equation is a line. Second one is a circle. I chose to use the substitution method again. So I took the first equation and solved it for x. So remember, once again, it doesn't matter which equation you use and which variable you decide to solve for, as long as you do it correctly, you still get the same answer, but you do want to move with the easiest route possible. So here, the easiest way was just to add y to both sides. I could have solved for y by subtracting x and then multiplying both sides by -1. But like I said, the easiest route was just to add y to both sides. And so I have x is equal to y plus 3. Now I'm going to plug y plus 3 in for x in the other equation. So my other equation was x minus 2 squared plus y plus 3 squared. And that's going to be equal to 4. Plugging in y plus 3 for x. So I have y plus 3 minus 2 squared plus y plus 3 squared equal to 4. See if I can bring that down some. All right. So now we can simplify this and then expand it out. So right here, 3 minus 2 is 1. So I have 1 plus y plus 1 squared, and then y plus 3 squared equal to 4. Expand that out. Y plus 1 squared is y plus 1 times y plus 1, y plus 3 squared, y plus 3 times y plus 3. And then you fold that out. You know, we're talking about y times y times 1, 1 times y, 1 times 1, y, 3, 3y, 3, 3. And why is this 4 red? Right, put it back. All right, so do that for in y squared plus y plus 1 plus y squared plus 3y plus 3y plus 9 equal to 4. Combine your like terms. 2y squared plus 8y plus 10 equal to 4. Set one side equal to 0. We're solving this quadratic equation now, so we're minus 4 from both sides. 2y squared plus 8y plus 6 is equal to 0. Go ahead and factor that out. So I pulled out 2, greatest common factor, and left me with y squared plus 4y plus 3. Factor out y squared plus 4y plus 3 gives me y plus 3, y plus 4. Set each part equal to 0. Y plus 3 is equal to 0, y plus 1 equal to 0. Gives me y equal to -3 and y equal to -4. All right. Now, once again, once we have our y components of our ordered pairs, we need to find the x. So we plug the values back into the original equation. So you see I'm using x equal to y plus 3. That goes back to this. I took my equation 1 and solved it for x. So x equal to y plus 3, plugging in -3 gives me 0. Plugging in -1 gives me 2. Now remember, those are our x's. And remember, don't forget your ordered pairs, x, y. So your x component goes first, then your y. So that's why my ordered pair is 0, -3 here, and then 2, -1 here. So always make sure you write your x first, then your y. And then down here, you see my rough sketch. We had a circle and a line. The line went through the circle at 2 points. So those are our 2 points. All right. Let's look at another one. Here we have 4x squared plus y squared equal to 13. X squared plus y squared equal to 10. Both of these are circles. All right. So here I'm going to use the addition method. So instead of trying to solve one of these equations for y or for x, notice that we have square each one of them. We can use the addition method. And I want to cancel out, or I can cancel out either the x terms or the y terms. Now, remember, we always want to go the easiest route. If I want to cancel out these, then I need to multiply x squared by -4 so that I can have 4 and -4 in front of x squared. Or I can just multiply one of these by -1 in order to cancel out. So I have y squared and -y squared. So that's the one I'm going to do. I'm going to take the second equation, multiply it by -1. If I wanted, I could have took the first equation and multiplied it by -1. But either way, what I need is one of my y squares to be negative so I can cancel out my y squares when I add them together. So I multiply my x squared, my second equation, by -1. That gives me -x squared minus y squared equal to -10. Notice that is my new equation 2, my new second equation. Now I can add my equations together. 4x squared plus y squared equal to 13. -x squared minus y squared equal to -10. My y squares cancel when I add them together. 4x squared minus x squared is 3x squared, excuse me. 13 minus 10 is 3. So that's my equation that I can use to solve now. 3x squared equal to 3. Divide both sides by 3. That gives me x squared equal to 1. To get the square off of x, you take the square root of both sides. And that gives me x equal to plus or minus 1. So don't forget the square root property. Whenever you take the square root of both sides, you have to use plus or minus. All right. So just like before, plug the values back into either equation to find the corresponding y value. I decided to use this one, x squared plus y squared equal to 10, only because I have smaller values. If you were to go back to your options, this has a 4 in it. This has 13 here. So I just use the one with the smaller values. Once again, it doesn't matter. Either way, you'll get the same result. So I use x squared plus y squared equal to 10. Plugged in +1. 1 squared is 1. Subtract 1 from both sides. I have y squared equal to 9. Take the square root of both sides. Y is equal to plus or minus 3. Over here, plug in -1. Well, -1 squared is 1. -1 squared is 1. Subtract 1 from both sides. I get y squared equal to 9. Take the square root of both sides. That's plus or minus 3. All right. So in both cases, I get plus or minus 3. So that means when x is 1, I get these two ordered pairs, 1 -3, 1 +3. And when x is -1, I get -1, -3, and -1, +3. So I have 4 solutions, and right here is once again a rough sketch of that. You notice we have the intersection at 4 different points because we have 2 circles. One is skinnier than the other. All right. Okay, so last one for the lecture anyway. We have y equal to x squared plus 3, x squared plus y squared equal to 9. So we have a parabola and a circle. I'm going to go ahead and use the addition method. If I wanted to, I could use the substitution method. I already have this solved for y, but you'll see why we did the addition method in a second. So remember, if you're going to do the addition method, both of your equations have to be in the form of ax plus by equal to c. So I subtracted x squared from both sides so I can line up my x squared to be able to cancel out. So even though we're dealing with powers higher than 1, it's still the same thought process. You want to have your constant on one side by itself and then your variables on the other side so you can add them and subtract them accordingly. So I subtracted x squared from both sides. Now I have -x squared plus y equal to 3. And I'm going to add that to the other equation. All right, so notice we have x squared plus y equal to 9. With -x squared plus y equal to 9. Let me see. Did I write something wrong here? X squared plus y squared, oh, the 9. I mixed up these. Should be a 3 here and a 9 here. X squared, yeah, okay, didn't look right. Okay, still doesn't change the result, but Just want to make sure my notes are right. So negative x squared plus y equal to 3. X squared plus y squared equal to 9. So x squared and negative x squared cancels out. Y is not added to anything. Y squared is not added to anything. They're not like terms. So you just bring them down. 3 and 9, add them together, you get 12. All right, so we have y squared plus y equal to 12. Set one side equal to 0 because we have a quadratic equation here. Subtract 12 from both sides. Y squared plus y minus 12 is equal to 0. Factor y plus 4, y minus 3 equal to 0. Set each piece equal to 0 and solve. So we have y equal to negative 4, y equal to positive 3 as our first components of our solutions. All right. Now we can go ahead and plug those values in to either one of the equations. I'm going to use the y equal to x squared plus 3. That was this one right here. And went ahead and plugged those in. So let's see what we get. So plug it in negative 4 for y. So it's negative 4 equal to x squared plus 3. Subtract 3 from both sides. That cancels on the right. Leave me with negative 7 equal to x squared. Now take the square root of both sides. That's the square root of negative 7 equal to x. And don't forget, the square root of a negative will always give you I. So that's plus or minus I square root of 7. Don't forget, whenever you take the square root of both sides, plus or minus, whenever you take the square root of a negative, you're going to have to use I to represent an imaginary number. All right. Then over here for 3, plug in 3 for y. Subtract 3 from both sides. I have 0 equal to x squared. Take the square root of both sides. I have plus or minus 0. So there's no such thing as a plus or minus 0. It's just 0. So that's just one value, x equal to 0. So when y is negative 4, x is equal to plus or minus I square root of 7. When y is 3, x is equal to plus or minus 0. In other words, just 0. So just one order pair. So when we look at what we have, plus or minus I square root of 7 are imaginary, and they're not valid solutions for us when we talk about graphing on a two-dimensional plane. And here, that means our only valid solution is when x is 0 and y is 3. So that's what we got right here. And then once again, here's my rough sketch of the parabola and the circle meeting at the vertex, which is 0, 3, the only point. That's the solution. All right. So try these out. Let me know if you have any questions.